This is a short presentation to support you in naming and understanding some of the properties of two-dimensional and three-dimensional shapes. The first thing to discuss is Greek and Latin number prefixes and also some suffixes that relate to shape vocabulary. If you can make children aware of the meaning of some of these prefixes and also related suffixes, it will really help them and you in naming shapes. So have a look at this information image here that's taken from Google Images that lists common numbers and their related Greek and Latin prefixes. And you will see that these are number prefixes that you will come across a lot within maths and particularly within shapes. It's also worth noting at the bottom here that the suffix lateral refers to a shape defined by lines, the suffix angle, a shape defined by angles, gon, a shape defined by the number of sides in relation to two-dimensional shapes, and hedron in relation to three-dimensional solid figures and faces. So, for example, if you think about the number prefix octo, meaning 8, an octahedron is a three-dimensional shape with 8 faces. So understanding and drawing attention to these number prefixes and the related suffixes can really help know what shapes you're talking about. The first thing to consider in relation to two-dimensional shapes is that shapes can be classed into particular families according to the number of sides they have. And this is where again we can see those prefixes helping us. These are all polygons, that's shapes with many sides, and they are named according to the number of sides. That tells us the shape family that they can belong to. And then we have simple classification into regular and irregular shapes. Regular meaning shapes that have all sides the same length and all angles the same size, and irregular shapes would not have all of the sides the same length. But of course we know that we can classify certain shapes, certain polygons further, and if we have a look at this image here, again, all the images on this presentation are taken from Google Images, and on these images here you can see how triangles can be classified either according to their sides into equilateral, which is another word for a regular triangle, isosceles or scalene, and also by their angles. So we can classify and name triangles according to their sides or according to their angles, and that's shown here. And we can also further classify quadrilaterals, and this image is useful because it shows us the quadrilateral family tree. All of these shapes here are quadrilaterals, but of course some of them are particular examples of quadrilaterals. So let's first of all have a look at the parallelogram family. Parallelogram is any quadrilateral which has two pairs of parallel sides. Parallel meaning sides that always remain the same distance apart and will never ever meet. So a parallelogram has two opposite pairs of parallel lines. A rectangle is a special example of a parallelogram. It's a parallelogram that has right angles. So a rectangle can be called a quadrilateral, it can be called a parallelogram, but it's also a rectangle. A square is a special example of a rectangle. It's a regular quadrilateral. It's also a parallelogram because it has two pairs of parallel sides. It's also a rectangle because it has two opposites, it has two pairs of equal sides. It's just within the case of a square, it happens that the two pairs of equal sides are also equal to each other, making it regular. So a square is a special example of a rectangle. And then we have a rhombus. A rhombus is also a parallelogram. A rhombus is a parallelogram because it has two pairs of parallel sides. It just happens that those two pairs of parallel sides are equal to each other, And it can also be considered to be related to a square, because if you pushed a square onto its side so that its angles changed and it no longer had right angles, you would end up with a rhombus. So this is a special family. These three are all examples of parallelograms. They're all special examples of parallelograms, and a square is a special example of a rectangle. We also have the kite here and a delta shape. A trapezium. Now, trapezium has just one pair of parallel sides, and an isosceles trapezium has one pair of parallel sides and two equal sides. And that's why it's called an isosceles trapezium. So those are special ways of classifying the quadrilateral family. Now let's have a look at some common three-dimensional shapes. And in some of the examples here, like a tetrahedron, an octahedron, a dodecahedron, a hemisphere, half a sphere, you can see those number names, number prefixes being important again. This is a triangular prism. It's an example of a prism, and we'll discuss prisms and pyramids on the next slide. But these are the common 3D shape names. So now let's have a look at some special examples of polyhedron. Polyhedron are three-dimensional shapes which have polygons as their faces. So polygons are shapes like triangles, squares, rectangles, pentagons, and so on. So any three-dimensional shape that has polygonal faces is a polyhedron. And here are some special examples of polyhedron: prisms and pyramids. So let's have a look at the prisms first. A prism is a shape that has a face uniformly along its length, and the shape that is uniform along its length gives the prism its name. So if you have a look at a triangular prism, it has a triangle all the way along its length. If you cut it along its length, you'd end up with two shorter versions of the same shape. That's technically what we mean by prism shapes, and prisms are named according to the shape of the face that goes uniform along its length. So we have a triangular prism, a square prism. Now you might be looking at a square prism and thinking, well, that's a cuboid. Yes, a square prism could also be known as a cuboid, and a special example of a square prism would be a cube. Just as a square is a special example of a rectangle, a cube could be a special example of a cuboid or square prism. A rectangular prism has a rectangle all the way along its length and could also be called a cuboid. Pentagonal prism has a pentagon all the way along its length, a hexagonal prism, a hexagon all the way along its length, and an octagonal prism, an octagon all the way along its length. Now you might be thinking about a cylinder at this point. In the primary school, I would be quite pleased if children were to be able to relate a cylinder to a prism, because that shows that they are able to see that a cylinder is similar to a prism in the sense that it has a circle all the way along its length. Technically, a cylinder is not an example of a prism, but as I said, I would be quite pleased in the primary school if a child is able to see the similarity between a cylinder and a prism. And then we have the pyramids, another family of polyhedron, and these are named according to their bases, but you can see with pyramids that they don't have that shape all the way along its length, that you then have other faces that meet at a vertex, this vertex at the top here. And this special vertex, if you like, which is where those faces meet, is called the apex, but it is a special example of a vertex of a pyramid. So pyramids are named according to the shape of the base. So triangular pyramid, also known as a tetrahedron, a square pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, and octagonal pyramid, and so on. So those are all special families of polyhedron. Now let's have a think about the cube, or 3D shapes and properties in a little bit more detail. We'll use the cube as an example. One way that we often describe three-dimensional shapes is related to the faces, the vertices, and the edges. So the face is normally the flat surface, the flat planar surface that a three-dimensional shape might have. So a cube has 6 faces. If you think about it, if you unfold the faces, you would end up with the net of the cube. So the faces are what define the net shape in that sense. So faces are flat, planar parts of 3D shapes. So a cube has 6 faces. Edges are where the faces meet. So here are the edges. And vertices, 1 vertex, 2 vertices. Vertices are where the edges meet. If you like, they're the corners, the special name for the corners of a three-dimensional shape. So these are the vertices. So on the previous slide, we looked at faces, vertices and edges. And now we're going to look at that in a little bit more detail. Here we have the regular polyhedron, known as the Platonic solids. They're regular polyhedron in the sense that they have all of the faces are exactly the same on these particular three-dimensional shapes, and as I said, they're known as the Platonic solids. So we look at their special examples of polyhedron. So we've got the tetrahedron, which is also a triangular pyramid. We have the cube, where all the faces are squares. We have the octahedron, where all the faces are triangles. We have the dodecahedron, where all the faces are regular pentagons, and we have the icosahedron, where all the faces are triangles. So these are the Platonic solids. Now, if we look at the faces, vertices and edges of the Platonic solids, you can see that we've got the numbers there, and you could also look at how many edges there are on every vertex and how many edges there are for a face and so on. And then you can see the nets of those solids. In other words, if they were to be made of paper or card, that's what you could, that could be the shape, the two-dimensional footprint, if you like, or the blueprint rather, that you could start with to make a three-dimensional version of that shape. Now there is actually a rule for a polyhedron that links the number of faces, edges and vertices, called Euler's formula, because what Euler found is that if you add the number of faces and vertices, it's always 2 more than the total number of edges. And that's true for polyhedrons. And finally, we're going to discuss some special considerations in relation to three-dimensional shapes with curved surfaces. So a sphere or a hemisphere or a cone or a cylinder would fall into this category. On the previous slide, we looked at faces, vertices and edges as a way of discussing and analysing three-dimensional shapes. And one of the things that might come up when you're looking at three-dimensional shapes is how many faces, vertices and edges would a shape like a sphere have? Well, this is where you can get into lots of debate because some people might say that a sphere has an infinite number of faces, because if you think about a regular polyhedron, as you increase the number of faces on regular polyhedrons, they tend to look more spherical in shape, just as with a circle, when we're thinking about two-dimensional shapes, with a circle, as you increase the number of sides of a regular polygon, it tends to look more like a circle. So some people would say that a sphere has an infinite number of faces. Other people would say that a sphere has 1 curved face. But if you think about our definition of a face, it's a flat, planar part of a three-dimensional shape. Well, in that sense, a sphere can't be classed as having faces because it doesn't have those flat, planar parts to it. So when you're looking at faces, vertices and edges, stick to shapes like prisms, pyramids and the polyhedron, and avoid shapes with curved surfaces like the sphere, the hemisphere and the cone and cylinder.